In the previous video, we have implemented the insert front function for a single linked list. Now in this video, let's implement the insert end function. So let me pass element and node star head pointer. So now let's create a new node star new node. Create node of type element. So now we will take one more auxiliary node pointer that points to the first node. So head pointer of link. So now check whether the first node is present. So if aux equal to null, that means if it is not present, so we can write this not operator instead of this. So if not of aux, then I will set the head pointer point to this new node. Else, meaning there is some element present in the linked lists, so we need to do the insertion in the end, right? So we need to traverse. So while aux of next is null, so while aux of next is not null, that means from the first element to the last element, I need to traverse. So aux equal to aux of link. This basically does is first it will be in the first point element, right? So the first node. So it will check whether this while loop will check whether the next node is present. So if it is present, it will jump to that node. So this will jump to the next node. Jumps to next node if present. In the case if the aux of link is null, that means the node is not present, then we need to insert here. So aux of link should point to the new node. That's it. And also we will increment the head pointers data part, saying that we have inserted a new element. So now let's write the function to insert middle, insert mi, or in between, right? So this will take the element and the head pointer, node star head pointer. I'll also take one more argument, position. So it's nothing but the index. So if it is, it can range from 0 to position can range from 0 to n minus 1. N is nothing but the number of nodes in the linked lists. So we will validate this condition. So if position is less than 0, that means it's in the negative, or position is greater than or equal to head pointers data, that means the number of node we have, we will just return this. Okay, I need to include the return type as well, right? So void, because it's not returning anything, void. So when you return nothing, so it's nothing but we are stopping this function from further execution. So we're just returning the control over to the next line of the execution in the main program. So now if the position is negative, or if the position is more than greater than or equal to the number of nodes, if it is 5, I can go from 0 to 4, right? So only then I can insert. So if it is more than, I will return. So if position to be inserted is 0, I can say insert front, and I'll pass element and the head pointer. Right, else if position to be inserted is equal to head pointer of data minus 1. So this is the last but one. I mean, from if it is from 0 to n minus 1, the position is like I have if I have 5 elements, the position is given as 4, then I can insert in the last. So I will call insert end element and head pointer. So else if it is an intermediate position, if intermediate position, first we need to traverse, so we will get a reference, right? So node star aux, or let me take it as current, equal to head pointer of link. Head pointer of link is the first node, right? So I will take one more node, new node. I will create new node with element as the data field. So we need to keep track of the previous node. So node star pre equal to null. Now let me iterate using a for loop, because we know how many nodes are present. So for I equal to 0, I less than position I plus plus. So let's consider an example now. So if this is my linked list, initial linked list, now the total number of nodes are 4. Okay, so if the position is 0, we are inserting the front, right? And if it is 1, we will insert in the next part, that is after the first node. So here, and the position is 2 over here, position is 3 over here. So if the position is 3, we need to insert here, right? So if the position is 4, we will insert in the last. So here it's not n minus 1, like number of nodes minus 1 is equal to number of nodes, and here if the position is greater than the number of nodes, we will reject it, right? Yeah, so here if you say if we have the position as 3, so it is the, in this part we need to insert the new node. So if you want to insert 35, you need to insert over here, right? So to do that, we need to traverse till this node. So for I equal to 0, our initially the current pointer will be in the first node, right? It will be in the first node. So you can go from I equal to 0, 1, 2, right? That is I equal to 0 to less than the position. Less than the position is from 1 less than this 3, that is 2. So we'll just go aux current equal to current of link. So in this case, we don't require the previous pointer. So now we are in this third node, right? And we want to insert in this part. So to do that, we will say current of link. But before doing this, so since the current pointer is now in the third node, we need to insert after this. So the new node's pointer should point to the next node of this third node, right? So the new node link should point to the current node's link, so that that node address is not lost. If you do that current node link to point to the new node, this node will be lost, right? So this will be eliminated. So in that case, we need to first pass the link from the new node to the next node of the current node. Then after that, we can pass the current node link to the new node, right? So to the new node. And finally, we will increase the number of data field in the head. Make sure you don't put this outside the else part, because every insert and an insert front has their own field to increment the head pointer, right? So let me show you how it looks. So 10, 20, 30 and 35 will be inserted in this part. So first you make the new node, this is the new node, point to the current node's link, right? Current node's link will be this 40, then current node's link will point to new node. So this is how we will establish the insert middle function. So let's put them into use. So after inserting these many, let me also call insert end 20, pass the head pointer, alt shift down, so let it be 25, 30 and 35. Now insert middle, this will take element that will be 100, and I will give the position of 0, so 100 should come first, and then let me give the head pointer. Let me give 150, and in the last position, so we are having 5 plus 4, 9 nodes, right? So let me give 9, and I will also give something bigger than that. 9. Okay, 10 we have because of this node. Okay, so let this be 200. So let's save this and try to run the code. So gcc space ssl. So everything's fine. So now you can see the total number of nodes is 11. So let me compare with the insert function here. So first we will insert in the middle, right? So at the 0 position, so it is 100, and the last position, that is 10th position, will be 150, as you can see here. And we don't have this middle inserted, right? So it should be not 11, this should be 10. So you can see here, right? 1 3 5 10 15 will be inserted in the front, and 20 25 30 35 will be inserted in the end, working properly. So we are having 5 plus 4, 10 and 11. Yeah, it's correct, so it's fine. So the 12th element, so 200 is the 12th element which start being inserted because the position is greater than the number of nodes in the linked list. So that's all guys, thank you for watching.